Hello, boys and girls. It's Mr. Malzberger. Welcome to another geometry lesson. Today we're going to talk about circles. Everybody loves circles, right? So to help make some decent ones, I'm going to bring out, I have a cap from some spices. Make a nice circle. All right, now a circle only has a few bits of information I can give you as far as sizes and dimensions. This is the center of the circle, or at least close enough, right? So if I draw a line from one side of the circle to the other, this distance is called the diameter. Diameter. So diameter is the whole distance across the circle through the center. Okay. The diameter can be any type of measurement, inches, feet, centimeters, meters. I'll just draw a circle and tell you what it is, and you just have to mark it down. There's only one other main bit of information I'm going to give you. And that would be, I'm going to switch pens here. That would be as if we go halfway, okay? So instead of going all the way across, what happens if I just go halfway across? Now realize this straight line can be rotated. If I spin the circle around, now it's horizontal instead of, or vertical. You know, it doesn't matter which way the line goes. Same thing with the half line. The half line is known as the radius. So the radius is halfway across the circle. Right? So, and it goes to the center, right? Halfway across the circle from the center. Okay. So those are the two main bits of information I can give you. The distance across or halfway across. Now there's one last thing. It's the outside of the circle. When you draw a circle, you're drawing this thing. And we call it a circle, right? But the distance around that circle is known as the circumference. Right? So it's like circle, and then fence, circumference, a circle fence. How far around the circle it is. Now I'm going to make a larger one here because I want to teach you about something called pi. So I'm going to use this glass right here to make a bigger circle. Okay. And here we go. All right, so there's a little bit larger circle. Now I'm going to put the diameter in this circle, right? So all the way across the circle. Now what I'm going to do is I'm going to show you, where'd my string go? Oh, it fell on the ground. There we go. So I'm going to take this string and I'm going to wrap it around this glass, right? See how it just perfectly touches at the end there? You see that? So this is the circumference of the circle. This is the distance around this circle right here, right? It's hard to get perfectly set without the glass there. So what I want to show you is the distance around the circle's relationship to the diameter, which is the distance across, okay? So I'm going to line this up. I'm going to mark it with a marker. Mark it with a marker. That sounds so perfect. So here is 1. right? See that line right there? That's one full diameter. Now let's move it over, line it up again, and there's 2 diameters. Line that mark up over here, and there are 3 basically. Now this wasn't perfectly done. I would have had to really measure it. But you see how there was 3 full diameters? So 1, 2, and 3. And there's this little piece left over. It should probably be a tiny bit smaller than that. It wasn't a perfect wraparound, probably a tiny bit too long. So what we find is that the circumference, we're going to use a big C for that, equals the distance across, which is the diameter, times how many times it goes around. It goes 3 full times, and then there's this little piece. Well, that little piece, if we measured it, turns out to be a decimal. It's 0.14159, and it just keeps going forever and ever. That's the size. If this was 2 inches across, well, this is going to be 6 inches plus a little bit more. See that 3 right there? That's the 3 times around that, or the 3 diameters that go around the circle. 3 full diameters plus a little bit more, okay? So this number is known as pi. It was, it's an ancient Greek letter, and since this was figured out, the relationship between the diameter and the circumference was figured out in ancient Greece, they said this Greek letter is going to represent this never-ending number. It never stops. It never forms a pattern. It goes on forever and ever. And never do the numbers repeat in any type of way that makes a pattern. So the circumference is the diameter times pi. This is not the marker I want. Let's go to this one. Now we always write that as pi, because this is actually a number, and then the d, because this is the variable. This is going to change. Pi is just a number. It's like saying 3.14 times x, right? We're only going to use 3.14 because once you get to the 1592, it's such a small piece of distance, it really doesn't change things very much. This is the standard number that we use for pi. So if I wanted to find the circumference of this circle right here, and let's say that this diameter right here is 4 centimeters, right? What I need to do is I need to take that diameter and I need to multiply it by 3.14. Now, hopefully you have a calculator, which I just realized I don't, so I'm gonna have to go pause the video and go grab one. I know I can do this one in my head though. It's 12, that's 40 plus 16, so 12.56 centimeters is the distance around this circle that has a diameter of 4 centimeters, okay? So this is just a pattern of what you do. When you're finding the circumference, when I ask you to find it, you're just gonna say, oh, I need to find the circle. How far around is the circle? I need to find the distance across the whole way and multiply it by 3.14 every time. That's what you do. Now the only difference is, what if I give you, well, actually, let's try just one, okay? 1 or 2. I'm gonna give you 2 problems right now for you to try of just these, or let's just do some. How's that? I don't really care. I gotta get a calculator here in a second, but I'll do a couple with you right now. So this one has a diameter where this guy right here, I'm not gonna give him a diameter. I'm gonna give him a radius, okay? That's gonna change things slightly. So if I say this one is 3 feet, and let's say this one is 4 feet. Why not? Doesn't really matter what I say the dimensions are. We don't really care. It's just this number is going to be multiplied by pi, right? because the formula for the circumference, that's what we're finding, circumference, is going to be pi, which we're going to use 3.14, times whatever the diameter is. So I'm going to do 3.14 times, I'll put it in parentheses, 3. And that's going to be 930 plus 12 is 942, and that's going to be feet. But see, this one's different, isn't it? This one, I don't give you the whole distance across. I give you the radius. Now, there is an actual formula. We will use this later for something else. Since the radius is half the diameter, we have to double this. So I'm going to take pi times the radius instead of diameter. But since the radius is half, I'm going to put the 2 in front. It looks weird. You're like, why would I do this? But the 2 is making the radius into the diameter, and the pi just sits there. They always put a real numerical coefficient in front of pi, even though it's just multiplying it, and then you'll put the variable. Or you could just think, hey, I'm going to double the 4 and do 8 times 3.14. 2 times 3.14, oops, that looks bad. Let's put these in parentheses. Times 4. Right? That's what this is saying. It's doing the same thing here by making the 4 into how far is the diameter. If the radius is 4, the diameter is 8, right? So I'm going to do 8 times 3.14. I can probably do that in my head too, but I do need to run and get a calculator. 8 times 3 is 24, plus 80 and 32. Well, 80 and 32 makes 112, so 24 plus 1.12 is 25.12. Use the calculator, please. I'm just forgot to bring it down. And the other calculator, which is on my phone, I can't really get to because it's recording. Okay, so these are circumference. I am going to give you 4 problems to do. I want you to pause the video. Complete all 4, 2, 1 and 2, have the diameter. So you're just going to multiply. 3 and 4, you have the radius, so remember you're going to do this number times pi, but you're going to double it to get the full distance across. All right? So pause the video, and then I'll solve them. If you want to do number 1, and then unpause it and have me do it for you, that would be fine, and then pause it and do number 2. You can do 1 at a time or all 4 at the same time. Okay, so here we go. Right now we have 3 as the diameter. Our formula for the circumference is pi times the diameter. Circumference means the circle is going to be 3.14 times however far it is across. So I'm going to do 3.14 times 3. And we did this actually as an earlier example. That's going to be 9. 3 times 3 is 9. And 14 times 3 is 30 plus 12, so 42. And that's centimeters. Okay. Number 2, we've got a diameter of 5. So that's going to be 3.14. That's pi, right? Times the distance across, which is 5. That's going to be 15 plus, that's 15, 20, 70. So 15.70 or 15.7 inches. Okay? Moving down to number 3. Number 3, we have a radius instead of a diameter. So you either can think, okay, halfway is 2, the whole way will be 4. Or you can plug it in to the formula that we showed before, 2 times 3.14 times whatever the radius is, right? So 2 pi r. We will see that again. Distance around, circumference. That's 4 times 3.14. That's going to be 12.56 feet. Okay, moving farther on to number 4, again, we just have a radius. If the radius is 3, the entire distance across, the diameter is going to be 6. So do 6 times 3.14, or plug it in 2 times 3.14 times 3, right? That's going to be 6 times 3.14. 3 times 6 is 18, plus 60, plus 24. Okay, so 18, 16, 24 make 84 millimeters. Okay, so that is practicing just circumferences. Now, back when you guys were in elementary school, you learned area. Now, you learned area with rectangles, right? You saw this. We talked about it briefly in the video about volume. That if this is 3 and this is 4, let's say meters and meters, the area of this plane shape, I'm going to divide this into 4, divide this into 3, and it shows me how many squares of this size, a meter by a meter, fit inside this rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 squares. Now, of course, the shortcut is just to do 3 times 4. Now, we can't find the area of the circle so simply because squares don't fit in very well. If you were to take a circle, right, and I was to just cut it up into as many little pieces as I possibly could, right? I'm going to use a smaller, finer pen for this. So let's draw a bunch of little lines. I'll cut it in half. I'll cut it into fourths, right? That would be, it's hard to find a good eighths. They're not going to be perfect because I'm just kind of giving you an example of this, right? If I just keep cutting. Now imagine I cut these into even more little pieces, right? Like little tiny slices, little tiny slivers, okay? Imagine I cut the entire circle out into all those little tiny pieces, and then I lined them up side by side, staggered, kind of like teeth. You know, teeth would fit in like with a pumpkin. So there's one there, and there's one here, and then there's one here, and then there's one there, and there's one there. And it would just keep going for a long time. And eventually what you would see is this makes a rectangle, right? Think it's kind of like staggered teeth like this. Not the best drawing, and I made them way too fat, but let's just say it looked like that. This right here, the height of this is the radius, right? It's the radius of the circle. And this part is the outside of the circle. So this right here is half of the half the circumference, and this is half the circumference of the circle. Well, we know that the circumference is pi times diameter. So if I was to cut that in half, divide it by 2, right? I could cut 3.14 in half, but it's really not 3.14, it's 3.141592, blah, blah, blah. So I could actually cut the diameter in half. What is half the diameter? That's right, it's the radius. So if I do half the diameter, I get pi times the radius. So that's what I'm going to substitute right here, pi times the radius. So if I was going to find the area like this, 3 times 4 would give me the 12. I would do the radius times pi times the radius. You may not remember this, but whenever you have something times itself, it creates an exponent. So 5 times 5, well, that's the same as 5 squared. It means the number 5 multiplied by itself, there's 2 of them. I could do 3 and then be 5 times 5, but what I'm going to use is just the 2 r's. So r times r is going to be r squared. So the area of this circle is going to be pi times the radius squared. That is the area of a circle, right? How many squares fit on that circle? That is how you find the area. Now, here's the key thing. We're not using diameter anymore. We're only going to use the radius. As a matter of fact, the diameter is only used to find circumference and not in any other formulas, really, area or volume of circular shapes. You're going to learn the surface area of cylinders later, and when you get to upper grades, you'll learn about volume of cones and cylinders. So let's do a couple practice ones. Okay, not my best circle. Here's the center, and I will give you a radius of, let's say, let's do 4 feet. No, that's a big number. Let's do 3 feet. Haha. Okay, so, oops. This is the radius. My formula is pi times radius squared, right? So I'm going to do 3.14 times the radius, which is 3, squared. Now remember, squared means that number times itself. It's not 6, it's not 3 times 2, it's 3 times 3. So that's 3.14 times 9. And I can do this, I know this one. 27, 90, and 36. 90 and 36 make 126. So it's 27, it's 28.26 feet. Now check this out. We're going to put a little 2 by the measurement, the unit of measure, because it's saying a 1 foot by 1 foot square. 28.26 1 foot by 1 foot squares would fit inside this circle that has a radius of 3, a diameter of 6. Let's do another one, because that's what we do. Okay, let's get a different radius. Let's make this radius 4 inches. It follows the same basic principle. It's pi times the radius squared. So 3.14 times 4 squared. It's not 4 times 2, it's 4 times 4. 4 times 4 is 16. Ooh, I still need to go grab that calculator. I could probably do this. Let's see. That's going to be 48. Ew. I know 14 times 14 is going to be 196. I need to go grab that calculator. I said 196, I wrote 192. Plus 2 more 14s is 28. So that's going to be 412. So 224? That sounds about right. So it's 2.24. That's going to be 48. So 50.24. Okay. Inches squared. All right, I'm going to do one more little example here, and I'll give you some to try on your own. Of course, I'll go over them. What happens, of course, if I do this? This is where the game changes, right? I gave you the diameter. Oh no, the diameter, whatever shall I do? Well, let's say I say this thing is 10 meters. Are you gonna do 10 squared times pi? No, you're not, because this is the entire diameter. What do we need? Radius. So you've got to cut that 10 in half and say the radius is only 5, right? This is what the R is. Radius is 5. So I've got 3.14 times the radius, which is halfway across, 5, and we're going to square it. 5 squared is 5 times 5, and that's 25. So it's 25 times 3.14. I don't know why I switched them, but I just did. That's going to be 75. And let's see, 12 quarters is 3, so and then 2 more is 50, so 350. So 75 plus 3 is 78.5 meters squared. Okay, I am going to give you a set of 4 more to try. We're looking for the area of these 4 circles. Pause the video, and we'll solve these. All right. Okay, so hopefully you have finished all 4 of these problems. If not, and you've only done one and want to do one at a time, that is fine as well. Here we go. We're finding the area of the circles. It's pi's r squared. It would be a lot easier to find the area of the circles if pi's are square, right? Because square things is easy to find. So I need the radius. The radius is halfway. So the whole way is 4. Halfway would be what? 2. The radius is 2. So I need pi. We're going to use 3.14. And I'm going to do pi squared, or radius squared, excuse me, which is 2 squared. So that's 3.14 times 4. We've done this one before. That's 12.56 meters squared. Number 2, I was given the entire diameter, so I need to half that and say the radius is 4 inches. So that's going to be 3.14 times 4 squared. And that's 3.14 times 16, which we did as a practice problem, didn't we? Yep. So that's 50.24 inches squared. Okay, so now let's do, these ones were given the way I wanted. I got the radius here, so I just have to do pi 3.14 times the radius, which is 3 squared. 3 times 3 is 9, right? So 28.26. You'll get to be familiar with some of these numbers because I use a lot of whole numbers. I don't give you a lot of decimals. So you start to memorize some of these. I can give you a lot of questions that work out to be answers you've already seen. All right, moving right along, I've got 5 centimeters here. So I'm going to take pi. I'm going to use that radius, and I'm going to square that 5. So that's 3.14 times 25, which on a previous problem we learned was 78.5 centimeters squared. Okay, let's take that away. All right, well, now I'm going to add one last little thing to our challenge. Okay, like I said, we are going to now look at semicircles, half circles, right? So the semicircle, we're going to do the exact same thing. We found the circumference of circles, the distance around the outside. We found the area within the circles. We're going to do the exact same questions. But with the semicircle, I'm not going to ask for this circumference. I'm going to ask for the perimeter. And the reason why is you do need to find the circumference. But if you notice, a circumference would be the whole distance around this circle. It would include that. So if I cut that circumference in half, I would get the arch, right? I would get this part. Would I get the distance across? No, I wouldn't. So to find this, I need to find half the circumference, so half pi times diameter, right? That's going to give me this part. But I also need to get this far across. So I need to go around the entire thing. So I'm going to add the diameter back to it. So let's say this was 4 inches right here. So I would do 1/2 of times 3.14 times the diameter, which is 4. And in the end, I'll add 4 back to it. Well, half of 4 is 2, and 2 times 3.14 is going to be 6.28. But I need to add this distance back in, so I'm adding 4 to it, right? And then 6 plus 4 is 10.28. And that's going to be inches. So again, finding the perimeter, not just the circumference. I'm going to find the circumference, pi times diameter. I'm going to cut it in half, divide by 2. And then I'm going to add the diameter back in to get the whole distance around that half circle. Let's try this one. Now, of course, it can get... There's different variations, but let's try this. Let's do 3 feet. These two, I'll give you the diameter, and down here, as I'm sure you can already expect, I'll give you a radius so you can see how we change things. Okay, so it's going to be 1/2, 1/2, that's a much better 2, pi, which is 3.14, and then times the diameter. The diameter is 3. In the end, I'm going to add that diameter back in. I'm going to, half of 3.14, because this is an odd number. I don't want to do 1.5. So half of 3.14 is going to be, 3 is 1.5, and that's half of 14 is 7, so 1.57, right? Because 1.5 makes 3, and 7 twice makes the 14, times a 3. So that's going to be 3 plus 1.5, so that's 4.5 plus 21. So 4.71 plus the 3. use a calculator. I can do this in my head, but I do not expect you to do that. You should have one on your phone, on your Chromebook, or just an old-fashioned one will work. And that's going to be feet. Now remember, since we're doing perimeter, which is like circumference, we don't do squared because it's just straight distance. How far did you walk? You didn't say I walked 6 square miles. You just say I walked 6 miles. Let's come down here and do some radius. Let's say the radius here is 3 inches. It's not going to be the same answer here because the diameter is going to be what? Double that. So it's going to be 6. So it's going to be 1/2 times 3.14 times the whole diameter, which is 6. Now I'm going to half that 6 because it's even. So it's going to be 3.14 times 3, and I'm going to get 9, and that's going to be 4 and 2. So I've done the arch. I now need to add in the diameter. The diameter isn't 3, it's 2 times 3, so it's going to be 6. This number here should be added back in. 9.42 plus 6, 9 and 6 make 15, so 15.42 inches. All right, let's say this one is, let's just make it fun, 4 centimeters. So same basic pattern. It's going to be half, right, and then pi, so 3.14, times the diameter. The diameter's not 4. The diameter is the whole way across, so 4 times 2 is 8. And then I'm going to add that 8 back in at the end. Half of 8 is 4. So 3.14 times 4, that's 12.56. And I'm going to add that 8. 12 and 8 make 20, so 20.56, and that is centimeters. Okay, so that's basically the perimeter, the circumference. How is area? Area is actually easier. We'll do the exact same problems, or the exact same semicircles, and we'll find the area. Semicircle, and we're looking for area. Okay, so let's say this is 4 inches across. Well, the area formula for a normal circle is pi's r square. So for this, I'm going to do 1/2 pi's r square. The one thing you cannot do is half this radius before you square it. You have to square it first. So I have 1/2 times pi, which is 3.14, times the radius. Well, this radius is, well, that's the whole diameter of 4, so halfway is going to be 2. It's going to be 2 squared. Of course, I'm going to add nothing back in. I don't have to add the 4 back in because we're not doing the outside. It's just half of a circle, so it's just half of the area, right? So I have 1/2, 3.14. I have to square this first, and that's going to be 4. Now I can half this because it's not squared. Half of 4 is 2. 2 times 3.14 is going to be 6.28 inches squared. Okay. I'll give you this one. Let's say this is 3 feet. If you want to try it ahead of me, pause the video. If not, just follow along. I need to take this formula. All I'm doing is plugging in one number, this number. 1/2, 3.14 times, the radius of, half of 3 is 1.5, and that's squared. Ew. Okay, well, I can't half the 1.5. I actually know what that is, but I'll show you on a calculator what it would be. 1.5 squared is going to be 2.25. So I've got 1/2, 3.14 times 2.25. I'm going to just do 2.25 times 3.14. That's this part. I get 7.065. Now I'm going to cut it in half, divide by 2. I get 3.5325 feet squared. Down here, let's do some radius, or radii. Let's I'm going to keep them the same exact as they were on the other page, right? I'll give you 4 centimeters here and 3 inches here. So again, it's 1/2 pi times the radius, 3 squared. Okay, so 3 squared is 9. So I have 1/2, I wrote pi, I should write 3.14. 3 squared is 9. Half of 9 is 4.5. So I'm going to do 3.14 times 4.5. 3.14 times 4.5 is 14.13, and that's going to be inches squared. All right, the last one, same thing. We're going to take a half because that's a semicircle. In the area formula, pi's r squared, and the radius is 4, and I'm going to square it. Oops, that should be inside there. So 1/2, 3.14 is pi. 4 squared is 4 times 4, which is 16. Half of 16 is 8, right? 8 times 3.14, that's 25, 25.12. I actually knew this one. And that's centimeters squared. Okay, so we've done area and perimeter. So here's a practice sheet for you. Pause this, and the first 2 are going to be perimeter. Remember to find half the circumference, add back in the diameter for both of these. I gave you radius here, make sure you double it. Then come down here, I gave you the radius here, pi r squared for this one. Same thing here, recognize I gave you the diameter, do not use 8. Okay, so pause it, and we'll solve this together in a second. All right, here we go. So, for the perimeter, I'm going to use half of the circumference, and circumference I remembered was pi, times the diameter, and then I'm going to add back in the diameter in the end. So I have 1/2 pi, which is 3.14, times the diameter of 7, and then later I'm going to add the 7 back in. Half of 7 is 3.5. which makes me want to do 3.14. Ooh, 3.14 times 3.5 is 10.99. And now I'm going to add that 7 back in for 17.99 feet. All right. The next one, number 2. I'm going to do 1/2 pi, which is 3.14. The diameter, well, this one I got the radius of 3, so twice 3, doubling it, right, is 6. But I'm halving the 6, so I go back to 3. So 3.14, 4 times 3, and I got to remember to add this number back in at the end. Could you stop that, Jay? 3.14 times 3 is 9.42 plus 6. Add the 9 and the 6, you get 15.42 inches, and that is that perimeter. As I'm sure you can hear, there's lots going on in my house. Just like yours, there's people working all over the place. It's amazing how noisy everything gets. So here we go, last 2, and then you're done. Yay. We've got the area of a semicircle. Remember, area is pi times radius squared. I'm doing the number times itself. So I have pi, which is 3.14, times the radius of 2. I'm going to square it. 2 squared is 4. 4 times 3.14 is going to be 12.56 centimeters squared. Right? Anybody? Anybody? Yeah. Someone might have caught me. It's a semicircle, so it's 1/2 pi times radius squared. So I still have to half this. That's what you're going to forget if you forget something, right? So half of this is going to be 6.28 centimeters squared. That's your actual answer. So here we go over here. I've got 1/2 pi, which is 3.14. See how this is repeating? We're just throwing the same numbers together. Radius squared. Well, the diameter is 8, so the radius is 4. So I've got 4 squared, which is 16. 4 times 4, right? So I've got 3.14 times 16. Half of 16 is 8. So 3.14 times 8. I know this one, that's 24. It's going to be 25.12. Right? Yes. And that's going to be meters squared. All right, so that is circles. We did whole circles. The distance around is circumference. The area inside, of course, is we're looking at how many squares there are. And we did semicircles. So your homework is going to reflect those questions. Take a photo or scan or do this work on a separate sheet of paper and attach it for full credit. And I'll talk to you guys next time.